So my name is Birkinshaw. I work for a company called Mirapar. We are a consultancy specialising in cloud and in media and TV. I'm going to talk about serverless content recommendations in AWS. So the particular case that I'm going to take is a reality TV streaming service. Actually, it's got slightly chopped off the top. So the service is called HeyU, and it's run by NBC Universal. The customer needs, they're pretty universal. I think this is visibility to most people. They wanted to show more relevant content to users. They wanted to surface more of the catalogue, so they felt that there were parts of their catalogue that people just weren't watching. And by doing this, the end goal was to increase stickiness and to reduce churn on the platform. Maybe you recognise some of these shows? These are your favourites, I won't touch. So Amazon Personalize, just a quick overview. So Personalize is a fully managed machine learning driven recommendation system in AWS. We could probably say it's serverless. We might have a bit of debate about the pricing model perhaps. We'll get to a bit later. So it takes in as an input a variety of different data sources. So you can have streaming data, real-time data, clickstream data, or data about what TV shows people are watching, for example. And you can also have batch-based data, so you can have historical data sets. You can ingest your content catalog, either batch or streaming as well. Then what this allows you to do is to train machine learning models. And there's a variety of different models or personalized calls and recipes that you can run against this data. And it's not just machine learning. There are also some business logic rules as well. So you can promote certain content, or you can filter recommendations based on different criteria. So you can implement that stuff too. And it packages it all very neatly. You don't need to know anything about machine learning. Don't need to be a data scientist. When you want to get the recommendations out, there's two different ways to do it. You can either hit a real-time recommendations API. That would be a useful API if you were integrating this into a TV app or into a mobile app, for example. And there's also a batch-based interface, so that's great if you are getting recommendations for marketing mailers, for example. The pricing model. So there's actually two models. The model on the right is the one that's been there since the beginning, and the model on the left is quite new. It's a bit confusing because it's very hard to make a direct comparison between the two. We might argue the case that it's not fully serverless because although you're not managing any servers, what we normally expect to see in a serverless pricing model is that when it's not being used, you're not paying anything. So in this case, it's not just a simple cost per transaction. There's a fixed cost in both models. So in the left model, which they call use case optimized. So use case optimized, they're trying to make it easy. They have some kind of package solutions. You can say, I'm a TV provider or an e-commerce vendor, and it will build a solution around it for you. So in this solution, the pricing is based on data ingest, which is tiny, so we don't care about that so much. The number of users that you've got in your data set, so not the active users, but the number in your data set. And then the main cost is the number of recommendation requests, and that's priced based on blocks of 1,000 requests. The old model, which they call the custom model, because you can do whatever you want, doesn't have these prepackaged solutions. In that model, then, you still got the data ingest part, which is common, but you pay for training hours. So that means when you train your machine learning model, which you need to do periodically, that you're paying for the training hours. And you also pay for they call them TPS hours, so it's transactions per second hours. So if you provision capacity on the recommender, where you're going to have 10 TPS hours, that means that this can sustain 10 transactions per second. And you'll build hourly on that. So if we do I want to get rid of that Teams thing. If we do a comparison, it's quite hard. So on the left, I've just taken, these don't come from any real customer. They're just some sample numbers. That's kind of like the Amazon sample calculation that I've tweaked a bit. So we say we're going to have 200 gigs of data ingest. We're going to have 1 million users. We want to have 5 transactions per second average. And let's say that's going to be 10 peak. So if we provision this for 5, we end up with $374 a month, which for recommendation system is pretty cheap. On the custom model, it's kind of hard to make a comparison. If we provision for our peak, which is 10 TPS, we end up with a very big number, so $1,500 roughly. But if we provision for, say, our average, then we end up with 800. If we provision for only 1, it's 226. And the funny thing with personalizing this mode is that although Amazon say that when you go above your TPS allocation, they can't guarantee performance, what I've seen actually in the field is that it's very fast, even when you've exceeded. And I've actually seen a system that's 10 times under provisioned, and it was still performing well. So it becomes very hard to compare these two. Before I go into the architecture in detail, I'll talk about some key architectural principles. And these are actually principles that we apply across all of our serverless projects. So first one is the concept of service-bounded contexts. So bounded context comes from a book called Domain-Driven Design by Eric Evans. I'm not suggesting that you read it, but there's loads of articles out there that are summarising some of the more salient points from that book. And one of the concepts which is really quite valuable is the bounded context. So the idea here is that you group together components that are operating in a similar domain. So here, obviously, our domain is recommendations, and we might have inside this logical grouping. We've got some APIs, we've got a database, we've got some machine learning, we've got some compute, and we group that all together. We call that a service. You can call it a microservice if you want. Maybe it's a mini service. I don't know. And the idea is that we kind of protect that boundary around our bounded context. So we have these well-defined public interfaces. So we've got, in this case, we've got a message queue on the left, data coming in, and we've got a GraphQL API on the right, data going out. And what we're going to say is that that's the only point at which any external service can talk to our bounded context. And there's a couple of reasons we want to do this. We want to make sure that we don't create a maintenance nightmare. So if we go and open up all of our internal stuff to external services and they come and get their fingers in there, then it means we can't change anything. So we have what we call CICD coupling. And we're trying to build systems that are loosely coupled so we have more flexibility. And also just think, like, if you have that many interfaces into your context, bounded context, then how do you test them all? Are you testing them all? I think that I've heard some people talk about concepts like, we're doing nanoservices now because we're using serverless, which sounds terrifying because there's no way they're testing all the interfaces and maintaining them and maintaining backwards compatibility. And if you want to change your database for different technology, you want to change from DynamoDB to Aurora, for example, how do you do that? Because everyone's coupled into your architecture. So one of these logical services or bounded contexts is deployed by one pipeline. It's deployed as a unit, and that's stored in one Git repository. So one service, one repo, one pipeline. The other principle is event-driven. So we've used event streaming for the data ingest where possible, so that we can have some decoupling, and also so that we can be near real-time. And there's some near real-time use case later that I'll talk to you about. I've got serverless on here. It's kind of stating the obvious, I guess, but I just want to say that again, that we have a serverless first strategy. This particular, so that means that everything's serverless and we adapt our architectures so that it'll work better with serverless. And then the final principle is GraphQL for the APIs. I don't know if people know about GraphQL. It's a HTTP API standard, which was open sourced by Facebook a few years ago. It's very popular, and it allows us to do enrichment really well. So we can enrich data from different sources. In this case, we want to take the recommended items from the recommender, and we want to enrich them with TV show metadata, images, titles, synopses, that kind of stuff. It also brings us some other benefits. GraphQL is self-documenting, and it's also got type safety. This is the detailed architecture. I appreciate it's probably a little bit small on this screen. So on the left, we've got a feed of content metadata updates. So those are coming from a content management system. And that means that whenever there's a new show, there'll be an event coming in there. Those are actually stored in a database in DynamoDB. The reason that we do that is so that we can do batch-based catalog updates if we need to. So we can, I'll come on to into a minute why we might need to do that. On the right, we've got interactions data coming in. So interactions are how customers are interacting with the product. So it could be clicks or likes or video views or whatever. These are the signifiers that people are interested in this content. And that's how we train the recommendation algorithm. That's again an event-based streaming flow there, so that's near real time. At the top is the API. So this is where the external clients come in and request recommendations. It's the GraphQL API that I talked about. And that is taking the recommendations from Personalize, and then it's enriching that data with the content catalog info, so that they can be rendered on the front end as tiles with images and text and whatever else you need. At the bottom, just down here, we have a couple of components that are handling updates based on cron triggers. So those cron triggers are defined in CloudWatch as CloudWatch events, and they trigger Lambda functions. One of those is retraining the model. So we need to retrain the model periodically because viewer behavior changes over time. And also the models themselves, now they're personalized, actually increase the quality of the models over time as well. And also when you're starting out, you won't have very much data. Your predictions won't be as accurate. And as you get more data into the system and you keep retraining, you'll get more and more accurate predictions. Although we train the model weekly, if new content comes in, then that content will be recommended to users within 2 hours. So there are some kind of like periodic updates that Personalize is doing automatically under the hood. And the way that new content is recommended, because no one's watched it yet, so we can't derive interaction-based data for that content, it's recommended simply by looking at metadata of the content. So if you've got genre, cast information, whatever you can supply, the system will use that. It will try to recommend that new content to people that have already watched similar content before. And finally, that last one at the bottom, that's just about we do a daily catalog, full catalog ingest. So we have this event streaming interface for catalog changes for new shows, for example. But when something gets removed from the catalog, there's no explicit remove command in the API on Personalize. So we just do a daily full batch to make a completely clean catalog import. Any questions about that before I go on?
Is this a Merapath thing, or is this an Amazon? Is this a Merapath thing, or is this an AWS thing?
So Personalize is an Amazon black box solution, effectively. You can put in the data and you can get the recommendations out the other side.
This is your wrap around it?
It's the wrap around it, exactly. Yeah. And actually, when we started this project, this was pretty bare bones. So we had to do quite a lot of heavy lifting, particularly deployment, that I'll get to later. So data requirements. Data preparation is the biggest challenge with any machine learning project. So you're probably going to have data from multiple sources. It's probably going to have some fields that are missing, probably some malformed data. Like you might just see like nulling quotes appear somewhere or stuff like that. So you'll have lots of stuff you need to figure out. There'll be date formats that don't match up between different sources. So you probably have to spend quite a lot of time on data cleansing. When you've finally got your data into shape, you can start to ingest that, and you can start to do some training runs and start to see how this is performing. The good thing is, though, that the basic requirements left for data are really, really simple. You just need to have this interactions data set to get going. And all you need for each interaction is an item ID. So it could be TV show ID or a movie ID or whatever, product ID or something like that. A user ID and a timestamp. That's all you need to get started. So you can already generate recommendations just based on users' behavior without knowing anything about what the content is. There are then two optional data sets. So we've got the items, which is basically your catalogue. And you can provide any fields that you want there. So you can have genre or cast or anything that you can think of that could be useful. And also the users data set. So here you could provide demographic data, you could provide location or age. And that brings me on to the next slide, which is about GDPR. So you've got to keep in mind GDPR. Every company's got a different risk profile for this, and every company's legal department have different ideas about what they want to do about GDPR. And the legislation itself is fairly vague, particularly on what anonymisation actually means. So a degree of flexibility here. I think it's always best to err on the side of caution. So we don't, for example, in any of the deployments that I've worked on, we don't use the user's data set, because that just seems a bit dangerous. We could do without that headache. Of course, the other data, the interactions data, is still personal data. So user IDs are personal data, for example. And what you're watching could, in the end, be sensitive, because it could be used to profile you, determine your religion or your sexuality, for example. And to comply with GDPR, we need to make sure that we clean up data after a certain amount of time, and also that we can fulfill these right of erasure requests. So when you can request a service to delete your data, we need to be able to handle that. Personalize, probably because it's American, doesn't support any of this stuff. So what we actually agreed, you can't go in and take data and clean up your data sets and retraining people, which is going to be millions of dollars potentially. It's not really worth it for a right of erasure request. So what we agreed in the last two big projects that we did this with, two different companies actually, was that we would do mapping. So all the user IDs that we get in, we will also generate a new user ID randomly, and we hold a mapping table. And the generated user ID is going to personalize. And then if we need to delete a user, we just discard the mapping for that user. So that makes that data anonymized, or perhaps pseudonymized, depending on how strict you are. Of course, encryption at rest and transit, it should be quite obvious these days. I said before that you didn't need much to get going with personalized, you just need the item ID and the user ID and the timestamp. So that meant that we could deliver this in. So what we did was we first just got something going using that really basic data set. That's like a simple recommended for you rail. And then we started features on top of that. So it was a quite small dev team. I think we had 3 developers, and we probably had something up and running, I think, in 2 sprints, so 4 weeks. And it was using Scrum methodology. The next thing after just getting that basic recommendation live was to add some new features. So one of the features was to filter out content that you've already watched. That is just a feature of personalize. So that was just a case of exposing it through the abstraction layer. And then the next thing was to add this items data set. So that was the catalogue data. And the benefit of doing that was that it gives you some slight improvement in the quality of the recommendations, but crucially it allows you to recommend new content that no one's watched yet. And then we added the similar items model. So the similar items model, that's the kind of Amazon use case of people that bought this also bought that. It's called collaborative filtering. The recommended for you one uses a neural network. It's basically it's predicting a series of events. And it's saying, based on what I've watched already, which is a series of events, what's going next? And this one is different. This is collaborative filtering. It's more like a kind of like a a network of connected interactions that can then be traced through like a tree. And then finally, we added the batch recommendations for marketing. So that's something I showed you at the beginning. You can request that Personalize just runs a whole batch of recommendations and it dumps the output into an S3 folder, S3 bucket, and you can pick those up. There's a couple of other things which Personalize have released that are quite interesting that we've got on the roadmap. So one is context metadata. So the idea is that if you're watching on a different device or you're watching at a different time of day, then you might want to watch different kinds of content. So if you're on a big screen device or a mobile, or perhaps if you're watching in the evening. So you can provide context metadata in your recommendation requests, and then it will use that to tell your recommendations. And then the last one is impressions feedback. So impressions feedback is that we want to give some real-time feedback to the recommender so it knows if it's doing a good job or not. So you have 5 recommendations in, and you the fifth one, then clearly that one should have been further up the rail, it should have been further to the left. So the impressions feedback is that you can provide that real-time feedback to Personalize exactly what people are clicking on. And you can start to learn from that as well. Look at my clicker. So you asked about accuracy. Someone asked about accuracy. Yes. So this is quite interesting. So what Personalize does when you train the model with the data is it the 2 segments. So the first or the oldest 90% is used to train the model, and the newest 10% is used to test it. So it will actually go and pull a bunch of recommendations for your users, and then it will see, did those users actually go on to watch that content or not? And there's a whole bunch of different metrics it spits out. That's a screenshot from the dashboard. And the one that I found the most useful, maybe the easiest to comprehend as well, is precision at 5. So precision at 5 is this concept that if you show 5 recommendations to somebody, what percentage of those were relevant? So if it's 20%, that means that one of them would have been relevant. So relevant was that the user went on to watch it, or they clicked on it, or whatever your interactions are telling you. So when we started, it was about 20%, the precision at 5, which is not bad. And then I think when we added the items data set, we got to 23.6. Oh no, actually 25.4. So we added like 2 percentage points by adding the items data set. And then recently, Amazon Personalized, they released a new model, and that bumped us up to 34%. So you can see as you're going the gains that you're making. And also when you start to trial out these things, you can very rapidly just do some prototyping and see what the benefits are going to be. And then you can make a business case whether or not you should implement a new feature.
Got a question.
Yep.
Specifically to TV watching, Specifically to TV watching and recommendations of that, how does the model track how much of a program you watch? So I clicked on it because it looked interesting. 30 seconds in, I saw it was some crap, and I switched it off. Is that tracked?
Yeah. So what we actually do is, okay, probably done a whole talk on this because it's quite interesting. We get a stream of bookmark events coming from the player, and we get those on some devices every 30 seconds. And with that bookmark event, we get the percentage watched. We've just basically set up a threshold. And what I did at the very beginning was I created a whole load of test runs in Personalize, and I trained the model with different thresholds. So I did like 10%, 20%, 30%. As you increase that threshold, then you're also training on less data. So the training is cheaper as well. So there's a kind of sweet spot somewhere where you can balance cost against the quality. And we found that was around 50%. So when the user got to 50%, then that was a good point. We threw them away. But what we don't want to do is to, if you've watched that TV show and you've been watching that for 30 minutes, and we've been getting a bookmark every 30 seconds, we don't want to register 60 interaction events, because then Personalize, I think you really like that TV show. You like it a lot more than when you were watching it on your iPad, for example. So we created something which we call a sessionizer, which runs in something called Kinesis Firehose in Amazon, which is like a streaming, kind of like a streaming ETL service, like a data transformation service which runs on streaming data. So what we do there is we basically have this concept of a tumbling window. And when you first get a bookmark event come in based on the user ID and the content ID, then a tumbling window is opened and starts. And that will stay open for, I think we said it's 15 minutes. And it will close 15 minutes and go. And at the end of 15 minutes it will close, it will spit out an event. So that increases our latency a bit. It means that when you watch a piece of content, it won't disappear from your recommendations rail for 15 minutes, which we figured out would be okay, yeah. So, but also that's just, that's architecture, right? That's trade-offs. There's no perfect solution. Performance, like a lot of people moan about serverless and say it's not very performant. I think the big question you have to ask there is like, how fast does it need to be? So in our particular case, the API average latency is 140 milliseconds, but the P90, which is a bit more representative, is 170, which for web is pretty good. So 170 milliseconds is the amount of time it takes for the recommendations to load. Of that, this underneath here is a breakdown from a tool in Amazon called X-Ray. So X-Ray allows you to look into a particular request that's come into your serverless architecture and to see how that got sent out to different services, excuse me, and what the latency was of all the different services. It builds a kind of mesh, a map, and you can see the latency for the different parts of that request. So in this case, personalized is taking 50 milliseconds, which is pretty fast. We do some caching, so we don't cache the recommendations directly because, of course, they're different for every user, and it's not like one user is repeatedly reloading the home page normally. The thing that we actually get the most benefit from caching is the static data. So I mentioned that we were enriching the recommendations responses with show data. So we've got the thumbnail, synopsis, cast, all that information. So we cache that, and we cache that inside the API layer in AppSync. And we get 88%, I think, cache hit ratio for the show data, which is pretty good. So that helps us with the latency. It also helps us a tiny bit with the cost. Just finally a bit on CICD. So I said that everything was serverless. The pipeline is also serverless. So the pipeline is using Amazon Code Pipeline and Code Build. When we first started personalized, it was very hard to provision. I don't know if people here are familiar with CloudFormation, but there was no CloudFormation support at all at the beginning, and we had to do everything with Python scripts against the API. So the team built a whole load of Python scripts which are run. They run here from AWS. You could also run them from Jenkins or whatever CI/CD tooling you have. Even today, there's only partial support, so you do still need to script some things yourself. In the second big implementation of this that we did for another global media company, we actually did it slightly differently, and we used Amazon Step Functions. And that was quite a lot more powerful. So I don't know if anyone's familiar with Step Functions, but you can basically create it's like a kind of flowchart each other, and inside those steps you can do different kinds of processing, and that was really powerful because it's a lot more visual, and also we could reuse some of those steps. So when you stand up a new environment, you need to import data, you need to train a model, and those things are actually useful in other contexts. So the retraining, as I said, is something we do on a weekly basis. Data ingest is something that training a model is something that we would do if we were, creating a new environment, or we were perhaps changing the schema, adding some new data fields. We'd have to ingest again and retrain. So those steps in that step function become reusable. So I think if anyone's getting into this now, then I think that's definitely a recommendation that I go with step functions.
Can I just ask a quick question? Is there any other IAC support other than CloudFormation? A lot of customers don't really use CloudFormation because it's secondary citizen in AWS because it's their own tool.
Sorry, can you repeat the question for the...
So the question was, do any other infrastructure as code solutions support personalize? So quite a lot of the IAC solutions compile to CloudFormation anyway. So serverless framework and CDK are compiled to CloudFormation. I don't know if there's Terraform support. I don't see why there wouldn't be, because Terraform uses the API.
Yeah, this is kind of the question because AWS tend to put features in Terraform before they put it in CloudFormation.
Yeah, so because the Python scripting that we were producing was hitting the same API that Terraform's using anyway.
Yeah.
And at the beginning, all of the examples for how to provision this were basically Jupyter notebooks with loads of Python code in, which is kind of makes sense because it's data science, right? And that's what data scientists do.
We're refreshing seeing step functions using deployment workloads rather than application like workloads, which seemingly is much more appropriate for a state machine, right? I mean, it makes perfect sense.
Yeah, because these deployments are just so complicated. Because if you think about importing a data set of, say, 200 gigs, well, that takes a while. And you need to wait for that and wait for those updates. Retraining the model takes a few hours. So there are some quite long-running processes here. It's not really the best fit for, even for the code build, which is just a Docker image sat there.
I was going to say, it feels like it's something that's better to organise using Lambdas anyway. Just from the point of view of big long running things that you want to check them every so often. Because then you can just keep checking and checking.
Yeah, absolutely. And I've seen quite a few teams that are just working in general with machine learning and use this a lot. And there was a point when Code Pipeline announced native support for triggering step functions. And a lot of people were very happy because it meant they were sort of freed from this. Yeah, because they just have these scripts become so complicated. And when you're debugging your scripts, you just got to go and basically look in the logs from a Docker instance. And you're tailing this huge, mess of logs. Whereas in step functions, it's all separated out nicely into the different parts on your graph. Any more questions?
Sorry if you said this already and I missed it, but does the recommendations workflow have any input from the user, such as, for the love of God, never show me anything with Adam Sandler in it?
No, so it hasn't got like a like or dislike type feature. You have to implement it yourself.
Okay.
No.
And that's just part of your own data set that you throw in that it then...
Yeah, so you could track that separately, and then just filter that out. So in this particular example, I showed you that we had that API facade that we built. I'm going to go back to it. So inside this API facade, we do like a little bit of processing. So one of the things that we do is switch between different versions of the recommender. So we've got an environment variable and the Lambda function that you can change. There's another customer that we work with where in the recommender they actually pull on-demand and linear recommendations separately. And then they have a kind of like slider that someone can adjust to say like how much VOD versus linear gets recommended at any one point. So you can do quite a lot of business logic in that intermediate layer. And that's one of the other reasons that it's good to wrap this thing, apart from the coupling. It's also flexibility.
Thank you.
Maybe a bit more specific than the Adam Sandler comment, but I worry its recommendations as self-fulfilling prophecy. Is it possible to kind of weight things that people have found organically through just searching for content at a higher value than things that have been recommended to people? Otherwise, everyone just watches what other people are being recommended and you never find anything that's slightly more niche. is there any weighting to that?
There's something else you can do actually. So when I brought this up, there's a metric here at the bottom right. It's tiny, so I'll tell you what it says. It says coverage, and it says 85%. So that means how much of your catalogue is being recommended in that sample, that 10% sample. And there are, within personalize, a bunch of parameters for each model that you can configure. And there's a kind of like exploration weight, I think it's called. And you can actually configure how much it should try to explore. So you can try to surface more of your catalogue. And this number is actually quite decent, 85%. But if that had been lower, then we would have increased the exploration weight.
By setting it higher, it's...
Yeah, if it was 20%, then you could have a problem because you just create a bubble and everyone's watching the same stuff.
Anyone else? Can we do Nigel on the way?
Just a very quick one. So when you're talking about pricing, you showed the training hours on the right hand model.
Yeah.
Is that something you can actually control? Can you say, only want you to train for 2 hours, or can you train for 1,000 hours?
No, it's based on your dataset size. And it creeps up over time. At some point, it will become a significant part of your cost. Also, if your dataset gets to a certain size, then Amazon will only look at a certain window. So there's a certain window of events that it will look at. I've forgotten what the figure is. So there does become a point at which it might become economical to clean your dataset and throw some of the older stuff away.
This is just from personal experience of Amazon Prime. Do we know if they use this engine for their recommendations?
So apparently they do, and there was
Which case, why is it so dreadful?
there was a paper that they released a few years ago, because the kind of model that's used for the recommendations at the time they started using it, I think was it was possible. They were pitching it as a new way to do recommendations, because everyone was doing collaborative filtering, and they were doing basically have a collaborative filtering model, and they would take the last 10 things that you watched or that you bought, and they'd put them all into the collaborative filtering model. They'd get the results back, and then they'd dedupe and rank them. And actually, it wasn't very accurate. It wasn't very good. And they pitched this new approach using this hierarchical recurrent neural network, HRNN, which is what Personalize uses. And they do say in their sales blurb, or they certainly did, at the time when we started, that it was used, it was kind of born out of the technology used on Amazon.com or something like that.
Yeah, it came out of retail.
Yeah.
Just seem to relentlessly show you the same shows.
I mean, who knows what business budget they have on top of that as well, of course.
So we've probably got time for one more question. We're already late, but anyone else?
Okay, I have one last one. Is there anything you need to do to deal with the difference between like films and episodic content? So if you watch like binge a series, is that going to boost that series too much?
Yeah, so the items that we store in the system are shows. So if you watch a bunch of episodes, that will boost it. We decided not to put in like episodes or seasons as items, then you could get very weird things like you get recommended an old season or something because you watched a new one. You get recommended season 3 because you watched season 6 or something. So the actual decision of which episode to show in a show is business logic.
So he does it at the show level?
We do it at the show level. There's a solution that we built for a broadcaster that does linear and VOD, and in there, inside one system, we have linear and VOD. But we have, I told you there's a feature in there called filtering. So there's an attribute on the items dataset, which is the type, linear or VOD, and you can then, when you call the API, you can hit the filter. And that's that case I told you about where we actually do 2 calls in parallel. We get the linear and the VOD, and then we can decide how much of each to show. Although now, there's a new feature called promotions in Amazon. You don't need to do that. You can actually ask Amazon to push up certain kinds of content. Because that double tap is quite wasteful when you think about it. Thank you.
Great talk, really interesting. Once again, big round of applause for our speakers tonight, Kieran and Chris. And see you next time. Thank you very much for coming.